Hello students, you will be having a paper discussion of RPT-3 at 8:30 p.m. Okay, try to have the papers along with you so that you can go through the questions while explaining. Okay, try to join at 8:30. Yes, note down the key first, everyone. Let's have a setting. Mark the key in this paper also. Yes, everyone is here. Yes, okay, everyone. So note down the key. Right. First question. Option 3. First question, option 3. Second question, option 2. Third one, option 3. Fourth one, option 2. Fifth one, option 3. Sixth one, option 4. Seventh one, option 2. Eighth one, option 2. Ninth one, option 1. 10th one, option 3. And 11th one, option 2. 12, 4, 13, 4, 14, 4, 16, 15, 1, 16, 1, 17, 1, 16, 1, 17, 2, 18, 2, 19, 2, 20, 4, 21, 3, 22, 1, 23, 1, 24, 1, 25, 1, 26, 1, 27, 4, 28, 4, 29, 1, 30, 2, 31, 1, 32, 3, 33, 1, 33, 1, 34, 2, 35, 4, 36, 4, 37, 4, 38, 4, 39, 2, 40, 2, 41, 2, 42, 2, 43, 1, 44, 1, 45, 3, 46, 3, 47, 1, 48, 1, 49, 2, 54. Okay? Yes? Any confusions? Have you copied every question? Yes, everyone? Right. Now, let us see the discussions, solutions. right? Okay, so students, if you have online students, if you have any issues with the voice clarity or board clarity, drop me a message in the chat box. Okay? Right. Can I have the chat? Yes, with the paper. Right, okay everyone. So let us see. First from last question we will see. From question number 50. Okay? From question number 50. Then last of motion part we will see after. First we will see from question number 50. Right, first question number 50. How many have attempted? 50th one. Question number 50. No one. Okay, then listen. It is given that the liquid kept in a cylindrical vessel of radius 0.3 meter is rotated with a speed of 2 RPS. RPS means revolutions per second. Revolutions per second. The difference in height, the difference in the height of liquid at the center of the vessel and at its sides is. So let's see quickly. Question number 50 is given that a liquid kept in a cylindrical vessel. We have a cylindrical vessel. This is a cylindrical shaped vessel. The bottom is also cylindrical in shape. Okay. And a liquid is kept in a cylindrical vessel of radius 0.3 meter. So radius of the C is R is equal to 0.3 meter and is rotated with a speed of 2 RPS, revolutions per second. So what is this? This is angular velocity. Angular velocity of rotation of liquid is given as 2 rotations per second or revolutions per second. Angular velocity is given. The difference in heights of the liquid at the center of the vessel and at its sides is. So there is a liquid is filled here. So when it is rotating, the liquid takes the shape of like this. Are you able to understand this? Liquid takes the shape of this while rotating. Right? So let us say this is 0.1, this is 0.2. 0.1 and 0.2. At this point, which is free to atmosphere here, just at this point, pressure at 0.1 is nothing but atmospheric pressure. Pressure here is also nothing but atmospheric pressure. But we are asked to find what is this? The difference between the heights. The difference in heights of the liquid at this center part of the vessel and its sides. Sides means maximum point is here at the side. So what is this difference? Height difference. From here to here, it is mentioned that this is cylinder is having radius r and rotating with angular velocity of this. That is the only given data. By using this, how can you find the difference between the heights? By here, to find this, we have to use Bernoulli's theorem. Bernoulli's theorem. What is Bernoulli's theorem? Bernoulli's theorem. From from Bernoulli's theorem, we know that sum of the pressure energy plus kinetic energy, sum of the pressure energy, kinetic energy and potential energy is equal to is equal to constant. So Bernoulli's theorem says that in case of a flow of liquids, fluid dynamics, whenever a fluid is in dynamic condition or state, then sum of the pressure energy, kinetic energy and potential energy will be constant. And it will be at two different levels. Levels means heights we observe. So if we can take this as a total height of this is h2, and at second point this is h1. h2, h1. Difference between this gives you this height. This is what you are supposed to find. H is equal to h2 minus h1. So to find this, we have to use Bernoulli's theorem. According to Bernoulli's theorem, at first point, total energy of the liquid in rotation is nothing but pressure at the first point plus kinetic energy of rho at velocity at first point v square plus rho g h1. Following this is equal to constant means is equal to the sum of these energies at point 2. So it is equal to pressure at second point plus half rho v2 square plus rho g h2. Rho g h2. Is it clear? So here if you observe this point 1, exactly at this point if you observe, this is exposed to atmosphere, this is also exposed to atmosphere. This is the pressure just at this point is equal to atmospheric pressure, here also it is equal to atmospheric pressure. So P1 is equal to P2 is equal to atmospheric pressure, so they will cancel out. And density, if it is same, now we can write it as rho V1 square plus rho GH1 is equal to half rho V2 square plus rho GH. Rho is common everywhere, so you can remove rho also. As what you want, the height difference. So let us write this as GH1 minus GH2. For GH2 minus GH1. GH2 minus, if you send this that side, you can write it as G into H2 minus H1. H2 minus H1. H2 is larger. Minus H1 gives you H. Right? H2 G into H2 minus H1 gives you is equal to what? Half V1 square minus V2 square. Is it right? V1 square minus V1 square minus V2 square. Yes or no? Right? But here you can observe that at this point, exactly near the side of the wall, the liquid will be sticking to the surface of the vessel. So liquid will be at rest at this point. Where? At V2. So because you can write here, V2 is equal to 0. V1 square by 2 it becomes. So this is equal to V1 square by 2. So G into H2 minus H1. H2 minus H1 is our H. Here H is nothing but, you can take here only. H is equal to H2 minus H1. We take that as H, and you can write from this as G into H is equal to V1 square by 2, or H is equal to V1 square by 2G. V1 square by 2G. So this is equal to, substitute the values. What is V1? Velocity, linear velocity is given, no, angular velocity is given, and radius is given. So the relation between linear velocity and angular velocity is what? Because V is equal to R omega. R omega, the substitute here, this becomes R square omega square. R square omega square by 2 into G. Right? So, substitute this. Actually here, revolutions per second means, we have to take this as not angular velocity. So rotational frequency is given. So it is usually linear frequency of rotation is given. F. Rotations per second. But angular frequency will be measured in terms of radians per second. So angular frequency here we express as 2 pi f. 2 pi f. So this you have to take it as 2 pi f whole square. Here it is f is 2. So you can write it as 2 into 2 pi into 2 is 4 pi. 4 pi radians per second is omega. Is it clear? So it is not angular frequency, it is linear frequency. Angular frequency is equal to 2 pi f. So if you substitute this here, then we will get this is equal to what? R square. R is how much? 0.3. 0.3 can be expressed as 0.3 meters or centimeters? Meters? Yes, meters. So you can write it as 3 into 10 to the power minus 1. Square is 9 into 10 to the power minus 2. 9 into 10 to the power minus 2. into omega square is 4 pi square. 4 pi square is 16 pi square by 2g. G can be taken as 10, right? So this can be expressed as what is this? 2 8s, 9 8s how much? And 8s. What is that? 9 8s how much? 9 into 8. 72. Okay, so it is 72 into pi square approximately can be taken as 10. Pi value is 3.14. Square is 9 point something, that can be taken as 10. So this 10 by 10 gets cancelled. So this is 70 to 10 is the power minus 2. 10 to the power minus 2. So it can be written as 0.72, or h is approximately equal to 0.7 meters. 0.7 meters. But in the options, if you see 0.01, 0.02, 0.04, 0.8 is given. So because 0.8 is near to this 0.72, actually taken G value as 10 here, but actual value of G can be taken as 9.8. If denominator is lesser, numerator will be greater than 0.72. So it will be nearly, approximately will be equal to 0.8 meters per K. Is it clear? Yes? Got down quickly. So to explain, it may take 10 minutes, a single question. But while practicing, you have to do this within 1 minute.
1 minute.
Only the practice can make you to do in 1 minute. Okay? Let's do it fast. Can I erase this part? Everyone? Right. Next question number 49. Question number 49. Finished? Right. Question number 49. It's given that water is maintained at. Just a second, guys. Let me bring the speaker. Are you getting the voice clearly? Last words. But I am shouting. Really feeling like. Oh. Better just wait a minute.
Akshaya?
Going on, whatever you guys are talking, that will be heard by clearly by others. So don't make noise. Yes, right. Finish with that, everyone. Fine.
Next, question number. Fine. Next, so you can check if anyone is sending any chat messages. There is any problem, so let me know. Guys, online students, someone ping me that are getting this clearly. Drop me a message. Online students, drop a message in chat box. Right, keep this. If you receive any message, just tell me. Right, okay. Okay guys, next question number 49. Quickly, it is given that water is maintained at a constant level of 4.9 meter in a big tank. The tank has a small hole to the wall near the bottom. There is a big tank. There is a big tank. Okay. And the water is maintained at a constant level of 4.9 meter in the big tank. Water level is from here. This water level is H. Let us take H is equal to 4.9 meter in the big tank. The tank has a small hole to the wall near the bottom. Somewhere here, it is having a small hole at the bottom, almost at the bottom. The bottom of the tank is 2.5 meter above the ground level. So that means this is on some support. This height, you can take capital H, is equal to 2.5 meters above the ground level. The horizontal distance at which water touches the ground is, so once the liquid is coming out and following this comes out, it may fall or strike the ground somewhere here. And following this, yes. So in this case, at what point from here, from this, at what horizontal distance it strikes the ground? What you are asked to find? The difference in, the horizontal distance at which the water touches the ground. From this point, what is the horizontal distance? We call it as range. It follows the path of a projectile, just like it is acting like a horizontal projectile, right? That's like horizontal projectile. So if you project this initial velocity horizontally, it goes and strikes the ground in parabolic path. So here, when water is coming out of this hole, it goes only in straight line path. So the velocity of ejection is also called as velocity of efflux. What is this? Velocity of efflux. You can take this as point 1, the stop point is 2. So here, velocity of efflux, it will be only in x direction, Vx. In y direction, there will be no velocity. So, all the conditions of projectile motion we have to apply here. What are those? Here no external force will act, only gravitational force act. So in x direction, as no force is there, acceleration will be 0. Acceleration only acts in vertical direction. All these points are to apply here. You have to remember projectile motion concept from motion in a plane. Then only can do it. Okay. Next. So to find this horizontal distance, the distance is nothing but velocity into time. With what distance it is moving in horizontal direction, this is the velocity. You can take this as dx, and into time, velocity into time. So you can take this as, let's take here R is equal to Vx into Vx is velocity of flux into time. But what is the velocity of flux? We don't know. What is time also? We don't know. But what do you know? Let us see the question once again. The water is maintained at a constant level of 4.9 meters in the big tank. The tank has a small hole to the wall near the bottom. The bottom of the tank is 2.5 meters above the ground level. The horizontal distance at which the water touches the ground. Only these things only given. Then how to find it? We have to just make use of one small relation called some equations of motion. Right? So first thing here, to find this velocity, we have to use the equation of motion which says that here, this is the initial, when water comes from here to here, when it is at rest, by the time it comes here, it gets a velocity of a flux. So by using the equation called V square minus U square equal to 2AS, and it is moving down, it is moving under gravity, we can take this as Vx. We can take it as Vx is equal to by using the equation V square minus U square is equal to 2AS or 2GH. H is this. Here G is down, H is also down, both will become positive and U will be 0. So Vx is Vx square equal to this, Vx is equal to square root of 2GH. Is it clear? On this equation, Vx velocity of the flux is square root of 2GH. Okay, where it is equal to square root of, let us keep this as it is at the end, we can substitute the values. This velocity of flux. Then what is time taken to travel from here to here? We call this as time of descent. Is equal to the time taken by the liquid jet to travel vertically downward this distance, this height. Time taken. To find this, you have to use another equation. S is equal to ut plus half at square. So time taken to travel vertical distance of h. This is vertical distance. You can take this as sy is equal to uit plus half a by t square. Where sy is nothing but capital H. Capital H is 2.5. So this H is equal to Uy is 0. Ux only is there. Uy is 0 plus half gt square. By using this you can write t square is equal to 2h by g. T is equal to t square equal to that. So t is equal to square root of 2h by g will be t. These two formulae you have to substitute here. Then you will get what do you get? It is equal to square root of 2g small h into square root of 2 capital H by g. This together you can write it as square root of, only in one root you can write it as, it is root x into root y. It can be written as root xy. So this is 2, it can be written as is equal to square root of 2gh into 2 capital H by g under single root, g gets cancelled, 2 into 2, 4h into capital H. H into capital H. S. So here 4 you can take it out. So 2 into square root of small h is how much? 4.9. Capital H is how much? 2.5. Are you getting this? 2.5. How much is this? Or you can keep this 4 here only. Is it 2h? Into 4 here only. Let's keep inside only. So 2.5 into 4 is how much? 2.45 into 4. 2.5 into 2? 5. So 4? 10. So 10. 4.9 into 10? 4.9 into 10? 49. So square root of 49? 7. Square root of 49 is 7. What is this? R is equal to 7 meter. Is it clear? That's it. So which option is right? Option 2. Option 2. Understood? Can I erase this one? Copied everyone? Copying or only listening? You have to copy quickly. Right. Next. Question number 48. Question number 48. Similar kind of question. Similar kind of question. You see here? 48. How many have attempted this? How many have attempted? Question number 48. No one. Okay, good. As the question is, the level of water in a tank is 5 meter high. 5 meter. The whole of area of cross section 1 centimeter square is made at the bottom of the tank. The rate of leakage of water from the hole in meter cube per second is given small g equal to meter per second square. So what is this? Question number 48 is given that there is a tank, okay, and the level of water in the tank is 5 meter. So it is filled with water to a height of h, where h is equal to 5 meter. 5 meter. The whole of area of cross section 1 centimeter square is made at the bottom of the tank. At the bottom of the tank, the whole of area, you can take this is A1. Area A1 is equal to 1 centimeter square is made at the bottom of the tank. Okay. The rate of leakage of water in the hole is rate of leakage. Rate of leakage is nothing but SS, the amount of the volume of liquid flowing per time, per unit time. Rate of leakage means rate of flow of water. Rate of flow of volume of water means d by dt of volume. Volume can be expressed as area into the thick length of the water occupied in unit time, which is flowing in a pipe. Okay, so it can be taken as area into the length by time gives you velocity. So the rate of flow of what is nothing but area into velocity. This is how much is the question. The rate of leakage is nothing but this. So to find this, because here area is given, velocity you don't know. How to find velocity? What is this velocity is called? Velocity of liquid coming down here is called velocity of efflux. Now to find what is the velocity of efflux, right? So, of course, h is given, right? You can find this by using two ways. One is by using the previous expression. What is velocity of efflux? Square root of 2g h. H is given here. Find out v. Area is given. Then you can find it. What is the rate of flow? Let's try. So q is equal to. Directly you can do it. To understand, you can discuss step by step. Here directly you can do it. What is A? What is A? 1 centimeter square. And 10 to the power 1 is 4. Velocity of efflux is square root of 2gh. Root of 2 into g is 10 into h is 5. 2 into 5, 10. 10 into 10, 100. So it comes out of the root and it becomes 10. So it is equal to 10 to the power minus 3. Yes? So which option is right? Which option is right? It is area is meter square, meter per second, meter cube per second. Meter cube per second is the rate of leakage or rate of flow of the liquid in a pipe. So this is how you can do it. Okay? Simple. Next. Question number 47. What is given here is a mercury drop of radius 1 centimeter. Copy this. Right, next. Question number 47. A mercury drop of radius 1 centimeter is sprayed into 10 power 6 drops of equal size. It is sprayed into, or means it is a, you can say it is, so it is splitted into. Sprayed means it is splitted into n number of smaller drops. Here n is nothing but 10 power 6 smaller drops of equal size. The energy expended in joule is provided. The surface tension of mercury is 416 10 power minus 3 Newton per meter. So how to calculate that? Let us see. You should remember the relation between surface energy and surface tension. So we have to just make use of one simple relation here. What you are asked to find? The energy expended in joule in this process of splitting a bigger drop into smaller drops. What is the energy difference actually? As energy expended means energy difference. The energy stored in a bigger drop will be actually energy stored in a number of drops minus energy stored in bigger drop. That is, we can take as change in energy. Question number 47. It is equal to 4 pi r square into n power 1 by 3 minus 1 into surface tension. Then you can use this directly, this relation. Okay? So here r is radius. Right? Radius of bigger drop is given how much? 1 centimeter. R is 1 centimeter and n 10 power 6. and the surface tension is given with the bracket 460 10 to the power minus 3 Newton per meter. You have to observe that whether all the quantities are in the same units or not. If not, you have to convert. All quantities should be in same units. Especially better to convert it as units. Okay? Here is equal to 4 into pi. To see the options, they are given in terms of numerical value. So pi is 3.14 into r is 1 centimeter. 1 centimeter means 10 to the power minus 2, whole square is 10 to the power minus 4 into n power 1 by 3 minus 1. How can you take n power 1 by 3 minus 1? Then let us take this separately. N power 1 by 3 minus 1 is n is 10 to the power 6, whole power 1 by 3 minus 1. So 3 1s, 3 2s, 10 to the power 1 minus 1, 10 to the power 2 minus 1. 100 minus 1 is how much? How much? 99. 99. What is this? Into T. So here this is 99. Its surface tension is how much? 460. 460 into 10 to the power minus 3. If you simplify all these values, you will get 0.057. 0.057 is energy expended in joule. Means the difference between energy of the split end drops and a bigger drop. Got it? So option 1. Next, question number 46. Camera is not covering. This part okay? This edge is not covering. Right. See here. Question number 46. 47 is done, right? 46. 46. So it is given that a ring of inner and outer radii 8 and 9 centimeter is pulled out of water surface with a force of what force? It is given that it is a ring. We have water surface. We have water surface. On this here we have a ring shape. Ring. Okay. It is a bed with some support handle. Ring shape. It is immersed in water. It forms a circular ring. Okay. Now we are trying to pull this out. So the liquid will be pulling down because of surface tension. Now the question here is, it is having inner radii and outer radii, 2 radii. Means the ring is kind of little thick ring. Inner radii and outer radii. So the point here is, surface tension of water is given as 79 per centimeter. Surface tension of water is T is equal to 79 per centimeter. So you are asked to find what is the pulling force. The force, the ring of inner and outer radii 8 and 9 centimeters is pulled out of the water surface with a force of how much? What is the force required is the question. What is the force required? Here you should remember the definition of surface tension. What is the definition of surface tension? T is equal to force per unit length. Force per unit length. This length limit you have to take it as effective length. Effective length is, so this effective length of this. We have a ring. The inner edge will be in touch with the liquid, outer edge also will be in touch with the liquid. So the effective length of inner edge is circumference of the inner edge 2 pi r or 2 pi r1. For outer edge 2 pi r2. So this L effective can be taken as 2 pi into r1 plus r2. F is this is here. Surface tension is given here. Asked to find what is the corresponding force. So from this you can take F is equal to 2 pi into r1 plus r2 into t. Alright. Now substitute the values. Here the options, if you see, options are given in Newton. So all other parameters also should be, Newton is SI unit. All other parameters also should be in SI unit. Here it is given in CGS unit. And convert this into SI unit. Alright. Or at the end, radii are given in centimeters. So that is CGS unit. This is also CGS unit. You can substitute all and you can get the final value. At the end you can convert the final answer into assignments. Okay? Otherwise now only you can convert and substitute and simplify. So do it. Simplify, substitute and find out the value. Substitute. 2 pi is equal to 2 pi. 2 pi is, the options are given numerical value, right? 2 into 3.14 into R1 plus R2. R1 is 8 centimeter, right? 8 centimeter, R2 is 9 centimeter. So 8 into 10 power minus 2, 9 into 10 to the power minus 2, 10 power minus 2, you take this out. So 8 plus 9 into 10 to the power minus 2 into surface tension is how much? 70 dyne. So if you want to convert this into SI units, dyne per centimeter. One dyne equal to how many newtons? 10 to the power? Newton equal to 10 power 7 or dyne equal to 10 power 7? 1 Newton is equal to
10 power.
1 Newton is equal to 10 to the power 7 dyne, huh? Right? 7 or 5? 10 to the power? 7 only? Right? So 1 dyne is equal to 1 by 10 to the power 7 Newton. So it is 70 into 10 to the power minus 7 centimeter. This is Newton. A centimeter is equal to how many meters? 10 power minus 2. Minus 2? And by 10 to the power minus 2 meter. So it goes to numerator and becomes 10 to the power minus 5. 17 to 10 to the power minus 5 Newton per meter. 70 into 10 to the power minus 5 Newton per meter. This is clear, everyone? Right? This is how we have to convert. Right? Next, so substitute the value here. 70 into 70 into 10 to the power minus 5. Now simplify. Simplify this. What is that? 10 to the power 5. Oh, not 7. 10 to the power 5. Sure? Yes, 10 to the power 5. Conversions. If I am doing wrong, you have to correct it. Okay? So you should be perfect. So 10 to the power 5. So it should be minus 5. By 10 to the power minus 1 centimeter equal to 10 power minus 2 or 10 power plus 2? Minus 2. 1 meter equal to 100 centimeters. So 1 centimeter is 10 power minus 2 meter. So minus 2 minus 2 cancel means minus 3 remains. Minus 3. So 17 10 to the power minus 3. So 17 10 to the power minus 3. Is it clear? Then simplify. On simplifying this, we'll get is equal to one more thing. The effective length I have taken for inner and outer. So then there is a long confusion. Otherwise, if it is a thin ring having single radius is given, you have to take for inner and outer 2 times you have to take. Effective length should be 2 times 2 pi r you have to take. That you have to keep in mind. So now this is equal to, on simplifying this, we get 7.48 10 to the power minus 2 Newton is the force required to pull this out. Let's do the calculations part by yourself. Is done. Can I erase this? Boys, girls.
Yes, sir.
Right. Next. Right, question number 45. It is given that when a U-shaped slider of negligible mass is dipped in a soap solution and lifted, a thin film of soap is formed in the frame. It supports a weight of 2 into 10 power minus 2 Newton. That film supports a weight of 2 into 10 power minus 2 Newton. If the length of the slider is 40 centimeter, the surface tension of the film of soap is, what is this? A U-shaped slider. So it is a U-shaped slider. This is U-shaped slider. Is lifted, immersed. U-shaped slider of negligible mass is dipped, immersed or dipped. So dipped in soap solution and lifted. A thin soap film is formed in the frame. it supports a weight of U-shaped slider. So slider means there will be a slider will be there. So that it is a U-shaped slider. It can slide on this U-shape. Okay. Now it forms a film. Provided it weights or it balances the weight of. It supports a weight of 2 × 10⁻⁻² Newton. The length of the slider is. That means we have to say surface tension is equal to here also force per unit length. Effective length I have to take. Force per unit length. Here this is effective length. So what will be the effective length? Here it is given that length of the slider is 40 centimeter. 40 centimeter. So if you substitute this value, then what will you get? What will you get? The weight. The force is nothing but the force which is the surface tension of the film. Directly I must prevent surface tension. The force is nothing but the weight supported by 8. It is given by 2 × 10⁻⁻² Newton by effective length is how much? 40 centimeters. So centimeter if you convert into meters, so it becomes 10⁻². So 40 10⁻². So simplify, what do you get? What do you get? Yes. 0.02. All in SI units only. If it is 2's, right? The weight is 2 × 10⁻². 2 × 10⁻². This is 40 centimeters. So 1/20. What is 1/20 value? 0.05. Into 10 to the power value, right? Actually here it is having, if you consider the slider, it will have 2 edges, 2 free surfaces. So for one side effective length is 40 centimeters, for the two sides 40 plus 40 you can take it as 280. So approximately you can take this as 2 to cancel 1/40. 1/4 is 0.25 into 10 to the power -1. So you can take it as 0.025 or 0.0025. What is this? Newton per meter. Newton per meter. 0.025. So if you observe the options, is there any option if it is having 0.025? No. But if you observe, this approximately can be expressed as 0.25 into 10 to the power -1 or 2.5 into 10 to the power -2 also you can write. So, but in the given options, instead of 2.5 into 10 to the power -2, 2 into 10 to the power -2 is given. But 2.5 is given, but 2.5 into 10 to the power -2 is there, not there. To confuse you, they have given like this. So, you have to consider the approximate value. Approximate value. So, it is 2.5 into 10 to the power -2, or we can take this as 2 into 10 to the power -2. This is the surface tension value. Is it clear, everyone? Newton per meter. SI is Newton per meter. Got it? Why you have taken this 2 here? Because the slider will have 2 free edges. So effective length will be one side length plus the other side length. 2 lengths you have to take. Right. Next. Question number 44. Question number 44. Yes. So what is given in 44th question? What is given in 44th question? Have you tried anyone? 44? What is the time? 9:25. Okay. Hi. Let us read quickly. So what is given and what you are asked to find, and what relation you have to use. These 3 points you have to understand carefully. So what is given here is for 44th one. It is given that a thin wire ring of 3 centimeter radius floats on surface of liquid. The pull required to raise the ring, the pull required means the force required, the pulling force. The pull required to raise the ring before the film breaks is 30.14 into 10 power minus 3 Newton, more than its weight. The surface tension of the liquid is, same relation, right? Instead of this U shape, a ring shape is given. Earlier I have dealt with the ring shape also with the 2 different radii, but it's a thin ring. That's what you have to be careful here. Okay? What is given here? A thin ring of radius. Its radius is R. R is equal to how much? 3 centimeters is equal to 3 into 10 to the power minus 2 meters is floating on the surface of the liquid. The pull required is F is equal to how much? 30.14 into 10 to the power minus 3 Newton, more than its weight. The surface tension of the liquid is, what is this? Correct formula. What is surface tension? P is equal to F by L effective. So for thin ring, so effective length is nothing but circumference. It is 2 pi r. But ring will have inner surface length and outer surface length 2 pi r into 2. So this is equal to F by 2 into 2 pi r one take. F is given, R is given. Substitute and simplify. Do it. Is equal to F is how much? 30.14 into 10 to the power minus 3 by 2 into 2, 4. 2 into 2 is 4. Pi is 3.14 into R is 3 into 10 to the power minus 2. Right? Yes. On simplifying this, we get approximately 18 into 10 to the power minus 3. We get 80 into 10 to the power minus 3 or 8 into 10 to the power minus 2 also can take. So options you have to follow carefully. Depending on the options, you have to simplify further. Your answer will be nearer to that. But you have to simplify it based on the options. This will be the surface tension. Newton per meter. Done. Next. Question number 43. Question number 43. So what is given here? It is given that if the shearing stress between horizontal layers of, so you have to remember the conceptual points to answer some cases, some questions. Concepts are very important. The shearing stress between the horizontal layers of water in a river is 1.5 millinewton per meter square, and the eta of water, what is this eta of water? Viscosity of water is 1 into the 10 power minus 3 Pascal second. Elastic gradient is. So this is related to which concept? Viscosity. Shearing stress. You should remember that shearing stress is proportional to elastic gradient dV by dx. So you can also write it as a shear stress is equal to some constant we call as viscosity into dV by dx. So you are asked here, shear stress is given, eta is given, you are asked to find elastic gradient. This is changing velocity with respect to the distance between the layers. This is called as elastic gradient. So any parameter which changes with the distance is called a gradient of that. Velocity is changing, elastic gradient. Force is changing, force gradient. Pressure is changing, pressure gradient will take. Potential is changing, potential gradient will take. In electrostatics we use the word potential gradient. So here you can take this as dV by dx is equal to, what is that? Shear stress by eta. So those values are given, direct calculation it is. So substitute and do it. What is the surface tension? 1.5 milli 10 power minus 3 Newton per meter square. It is in SI unit. And eta is 10 power minus 3 Pascal second. So that is also in SI units only. So okay, done. What is the answer? That's it. Yes. What is the unit? Velocity gradient means velocity by distance. Velocity unit is meter per second by meter. Meter cancel. So what will be the unit of this? What will be the unit of this? Per second. So this kind of questions also may come across. Which of the following represent the unit of velocity gradient? Meter per second or per second square, per second cube, etc. You should know. Next. 42. 42. Right. We're done. Can I erase this part? Finished? What finished? Very good, very good. Copy? Copy? Time up? Yes? No? Time up? 9:30. So we have just 30 minutes more. Okay. We'll try to at least do some 3 or 4 questions in half an hour. Actually, we have to do 30 questions. 30 minutes, but we cannot. Right. See question number 42. 42 is given that the mouth of the tap, at the mouth of the tap, the area of cross section is 2 cm square, or the speed of the water is 3 meter per second. The area of cross section of the water column 80 cm below the tap is take G is equal to meter per second square. How to do it? So you have to use that. This is a tap. One tap. What is given here? Let us say this is the first point, and here the area is A1 is equal to 2 cm square, right? And the speed of the liquid here is V1 is equal to how much? 3 meter per second. So you have to convert this into meter square. 2 into 10 to the power minus 4 meter square. This is meter per second. Then the area of cross section of the water column 80 centimeter, and step below h is equal to 80. H is equal to 80 centimeters. Is equal to 80 into 10 to the power minus 2 meter. What is area? Let us say A2 is how much? Is the question. So here we have to apply equations of motion. When water is falling from the tap, it falls down due to gravity. So you can consider here initial velocity is this. Initial velocity after traveling through a distance of this, what is final velocity at find? This is second point. This is first point. This is second point. At second point, so it will have some area, of course. What is this velocity and hence what is this area? Then you can find it by using equation of continuity. First, to find the velocity, you have to use equation. What is that? V square minus U square equal to V square minus U square is equal to 2AS. From that, V is this, U is this, V is V2, V2 square minus U is V1 square. V1 square is how much? Directly you can take 9 is equal to 2 into A is G, 2GH you can take. So G is 10, H is 80 10 to the power minus 2. So this one, this 0 cancel with this. So 2 into 80, it is 16. So 16 minus 9, V2 square is equal to 16 minus 9 is how much? 16 minus 9. Minus 9 or plus 9? Oh, this is minus 9. If it goes there, it becomes plus 9. Right? So 16 plus 9, 25. So V2 is equal to 225 is equal to 5 meter per second. So at this point, if it is the velocity, what is the area? To find the area by using velocity, you have to use the equation called equation of continuity. What is that? Equation of continuity. From equation of continuity, what do you know? AV is equal to constant. Write down this. From equation of continuity, AV is equal to constant, or A1 V1 is equal to A2 V2. Right? Here we know A1 V1, you know. V2 just you got, from using that you can find out A2. So A2 is equal to what? A1 into V1 by V2. A1 is how much? 2 into 10 to the power minus 4. Into V1 is how much? 3 meter per second. V2 is how much? 5. 3 by 5. So this is 2 into 5 is 2 into 3 is 6. 6 by 5. So it is equal to 6 by 5 into 10 power minus 4 meter square. The options are given in meter square or 50 meter square. You have to observe. Then accordingly you have to simplify. Yes? You are feeling boring, huh? Let's go down, go down. Question number 42. Question number 42. So, what do you get? So, this is 5 ones, 1 remains, 5 twos, 1.2, 10 power minus 2, 1 minus 4. Minus 4 meter square or centimeter square, if you want to write, it becomes 1.2 centimeter square is A2. A2. Okay? Right? So, which option is right? Which option is right?
All options minus
Option 2. Next, question number 41. Quickly. 41. Right. What is given here? Fast, fast, fast. Should move out of the room till completes. Right. Question number 41. If If 484 joule of energy is spent in increasing the speed of a wheel from 60 rpm to 360 rpm, moment of inertia of the wheel. Moment of inertia is there? Rotational motion is there? Rotational motion. Is there or not? Moment of inertia. So, energy spent in increasing the speed from rotations per minute. Moment of rotational motion part is in laws of motion, not there. Circular motion. Circular motion is there, but the rotational parameter is not. Motion in plane is there in the motion. Motion in a plane is there. Motion in plane, laws of motion, 2 chapters are there. Out of the motion. Okay. So maybe by thinking that you have gone through already, they have given. Okay. So fine. Then how to do this? 484 joule of energy is spent in increasing the speed of a wheel from 60 rotations per minute to 360 rotations per minute. So, what is moment of inertia? Moment of inertia. So, can you say energy kinetic energy is equal to half mv square. Kinetic energy is equal to half mv square for translational motion. For rotational motion, kinetic energy is half I omega square. Come, right? But kinetic energy is also right. This the energy spent in changing the velocity can be taken as delta k is equal to half I into delta omega square. Delta omega square. The energy is given. Omega is given. Omega whole square means omega 2 minus omega 1 whole square. Right? This is given. And we are asked to find I, moment of inertia I. So I is equal to delta k by 2 delta k by delta omega square. And substituting these values, what are these energies? 2 into 484 by delta omega is omega 2 minus omega 1 whole square. Omega 2 is 360 minus 60. So actually these rotations per minute is given. It is linear frequency. You have to take F is F1 is 60, F2 is 360. Rotations per minute. Rotations per minute. Per second if you want. Per second if you want. You have to multiply divide by 1 minute equal to 60 seconds. So it is equal to 1 RPS, rotations per second. It is equal to 360 by 60. So it is equal to 6 rotations per second. That is F2. So by using omega Here delta omega is omega 2 minus omega 1 is equal to 2 pi into f2 minus f1. That is 6 minus 1, 5. So 2 pi into 5 is 10 pi. 10 pi is omega, delta omega. Whole square is 100 pi square. Again, pi square also we take approximately as 10. And you can take it as 10 square is 10 power 2 into 10 is 10 power 3. 10 power 3. I'm simplifying this approximately. What do you get? Yes. Moment of inertia should be approximately 0.3 kg per meter cube. Kg meter cube. Kg meter cube. Moment of inertia should be meter square. The units the printing is printing mistake is kg meter square. Kg meter square. 0.3 kg meter square. Approximately 0.3 kg meter square. Okay. Next. Question number 40. Question number 40. If you are not following means you are not studying, you are not preparing the study hours. You have to spend some extra efforts. That is what you have to understand, and you have to increase your efforts, you have to improve your efforts. Okay? So this is already a number of times I have stressed. We are in crash course program. So we have to go as fast as possible. So to go that fastly, you should have an idea of all these basics. If you not, it is very difficult. So you have to spend some extra time to revise and remember all these points. When I am giving you a formula, you should be able to recollect that quickly and only can follow. Okay? Otherwise you have to spend some time and read and write and practice and remember. Yes, next question number 40. Question number 40. Is that done? Finished? Yes? Question number 40 is given that the reading of pressure meter attached with a closed water pipe is 3.5 10 to the power 5 Newton per meter square. Let's say pressure meter means initial pressure P1 is 3.5 10 to the power plus 5 Newton per meter square or Pascal. On opening the valve of the pipe, the reading of pressure meter is. So that is, we have something like we have a pipe. It is closed. It is fitted by using some arrangement. It is fitted. So here we have a pressure meter. Somehow it is arranged here. Pressure meter is giving a reading of this much. Pressure is pushing. It is exerting a pressure on the area. The pressure per unit area is called. Force per unit area is called pressure. So that pressure is giving this. Now, once you open this lid or valve, if you open this valve, the water starts flowing. In this condition of flow or dynamic condition, pressure is observed to be P2 is equal to how much? What is this? Question number 40, right? Right. So on opening the valve, the reading of pressure meter is 3 into 10 to the power plus 5 Newton per meter square. Calculate speed of the flowing water. Let us say initially it is at rest. Water is at rest in the pipe. Once it is opened, it starts flowing. So what is this? So here to find this, you have to apply which equation? When liquid is flowing, energy possessed by this is sum of pressure energy, potential energy and kinetic energy. So which is the law which consists of all these three energies? Which theorem? Bernoulli's theorem. Bernoulli's theorem says that pressure energy plus half rho V1 square plus half rho GH H1 is equal to, once it is opened, it is P2 plus half rho V2 square plus rho GH2. Because before opening the valve and after opening the valve, the liquid level is same and pipe level is same, so heights are having the same difference. So this minus this will be 0. Vanishes. And initially when it is closed, first case it is closed case, second case is open case. So initially it is closed, this velocity is 0. This is done. Next we can say Once it's open, what is the velocity asked to find? P1, P2 values are given. So from this you can write half rho V2 square is equal to P1 minus P2. Directly you can take. This minus is how much? 3.5 minus 3. 0.5. 0.5 into 10 to the power 5. So here V2 is equal to 2.5 into 2, 1 by rho into 10 to the power 5. What is rho? Density of water. 10 power 3. But remember, density of water is 1000 kg per meter cube or 10 power 3. So you can directly take this as 10 to the power 3. 10 to the power 5 by 10 to the power 3. How much? What is the answer? Is it 2 into 0.5 is 1 only? 1. And here it is V2 square. V2 square is equal to this. So this cancel and becomes what will be remaining here? 10 to the power 2. V2 square is 10 power 2. V2 is 2 times 10 power 2 is 10 meter per second. That's it. So which option is right? That's it. Okay. So you have to understand by reading the question what is given here and what you are asked to find, which relation you have to use. To understand that, you should have enough idea of how to deal with the question. Okay. Next. Question number 39. 39. Can I? Yes, let me take it. Only? Oh, okay. So they're feeling that easy. So numericals usually you cannot do slowly. So I am doing very slow. So you have to do little faster. So you have to finish all by now at least some 25 questions or 40 questions. I am doing very slow. Right, next. Question number 39. Done?
Yes.
Others? Finished? Right, very good. So question number 39. It is given that an inverted U-tube has its two limbs in water and kerosene contained in 2 beakers. If water rises to a height of 10 centimeter, to what height does kerosene of density 0.8 gram per cc rise in the other limb? Right. So what is going here is there are 2 beakers. This is 1 beaker. This is another beaker. 2 beakers. They are having, 1 beaker is having water, another is having kerosene. One is having water and another is having kerosene. Now the U-shaped tube is, an inverted U-tube has its limb in this water and kerosene. Inverted U-tube, this is U-shaped tube actually, is inverted. So this is having this kind of position. Are you following everyone? Right? Now the question here is, when inverted U-tube has its limbs in water and kerosene contained in 2 beakers, if water rises to a height of, this raises to a height of, let us say H1. H1 is equal to how much? Raised to a height of 10 centimeter. What height does kerosene raises here? Let us say it raises to some height H2. Okay, so what is that height? H2 is what? Provided density of kerosene is equal to 0.8 what? Gram per cc, centimeter cube. So you have to remember that density of water in a CGS unit is 1 gram per cc. Okay? And here, how to do this? How to do this? You have to remember that at this level, because we are measuring the height from here, at this level, pressure here is equal to pressure here. There is nothing but atmospheric pressure. So the pressure difference due to this inside this point should be equal to pressure difference at this point due to this height. Pressure difference is given due to liquid column. Can be taken as H rho G. H rho G. H1 rho 1 G is equal to H2 rho 2 G2. Because pressures are due to the liquid columns are equal. Because at the same level, the pressure here is equal, should be equal to pressure here. The same horizontal level according to Pascal's law. The pressure should be same. Now here, what is given? H1 is given, and G is constant anyway. G is constant, it is cancelled. So we are asked to find H2. From this you can say H2 is equal to H1 into rho 1 by rho 2. Yes, that's it. So H1 is how much? 10 meter centimeters. 10 centimeter. So it is equal to 10 to the power minus 2 meters. 10 into 10 to the power minus 2. Rho 1 is, first one is water, right? So water density is 1 by, for kerosene 0.8 gram per centimeter cube. All are CGS we don't let us take. So 10 by 0.8, how much? 10 by 0.8. Options. Based on options, you have to simplify. If you simplify this, you can multiply 10 by 10, 100 by 8. 100 by 8 is 12.5. Is equal to 12.5. What is this height in centimeters? 12.5 centimeters. Got it? Next, 38. Direct theory question. It says that in the given statements, the correct alternative is. In the given statements, the correct alternative is. The first option says SHM is necessarily periodic. SHM means simple harmonic motion. Necessarily periodic. SHM is necessarily oscillatory. Oscillatory motion may be periodic. All of the above. Simple harmonic motion is periodic. Necessarily periodic motion means the one which repeats after regular interval of time. It may be oscillatory or circular motion, whatever it is. It should be periodic. Yes. Simple harmonic motion is necessarily oscillatory. If simple harmonic motion is anyway, what is it? Periodic. Circular motion also periodic, but it is also periodic. Simple harmonic motion is a to and fro motion. It is oscillatory. To and fro is oscillatory. Yes, this is also necessary. An oscillatory motion may be periodic. Yes, it is periodic only. It repeats after a regular interval of time. Yes, this is periodic only. All of the above. Yes, all of the above are correct statements only. So the fourth option is right. Okay. Next, question number 37. The period of oscillation of mass m. The period of oscillation of mass m suspended from a spring of negligible mass is t. If along with it another mass m is also suspended, the period of oscillation will now be. So in case of spring mass system, have you copied this part? You can erase. Right, 37 is given the time period of oscillation of mass m suspended from a spring of negligible mass is t. So let us consider a spring mass system. Is a rigid support, the spring to this mass m is attached. When it is pulled and released, it oscillates. The period of what? What is the period of oscillation of spring mass system? 2 pi into square root of m by k, where k is force constant of the spring. Where k is force constant of the spring. Okay. Now, the second case, so to the same spring of spring constant k, along with this body, another body of same mass is attached. So, the total mass becomes 2m. So, what is that? This is T1 is equal to, let us say, T. So, what is T2 is the question. What is T2? 2 pi into root of, what is mass here? 2m by k. So this you can write it as, here, T2 is 2 pi into square root of 2m by k. So this you can write it as, if you bring this root out, if you write in this form, you can write it as it is equal to root 2 times 2 pi into 10 by k, that is t. So T2 is equal to root 2t. That's it. So which option is right? Which option is right? Fourth option. That's it. Okay? 4 minutes. Okay then. So anyway, I will wind up here as already time up. You have already might be scolding me. No? Not angry on me? Right, very good. Then you are good physics students. Right. Then so try to, for the next upcoming part test, try to prepare, revise whatever you have discussed till now, this today's session, revise properly and come for next session. Okay? So online students, 1 is there or 0 is there? 2. Oh, nice. Okay guys.